So like we do normally in class, after we kind of finish a lesson and maybe go through these situations and things like that, we have to summarize them with some key ideas, vocabulary, examples, all that good stuff. So be careful. Remember, this is on the back of the actual meaningful notes for 2-1. So make sure you go back a page, don't go forward a page. You want to make sure that yours says S&S problem 2.1. So our topic, guys, we can actually label this. I'm trying to make sure I get this centered here. We're going to call this the Wump family. And hopefully you can see the pink. If not, let me try zooming in a little bit so you guys can see that. But that's the Wump family. And we can be even more specific, and we can mention that we were drawing similar figures. And if you remember, we did that with the rubber band experiment. This is just another way of doing it with some guidance on a coordinate plane. So pretty much the key ideas. There's no new vocabulary for this, but let's talk about some key ideas. So we can actually put that over here in our top box. And I want you to remember that for this particular explanation, we're starting with an XY coordinate rule, right? And that is the original coordinate rule. In order to create a similar figure, you have to multiply both the X and the Y coordinate by the same value. If they are multiplied by different numbers, or you only multiply one of them, it will not make a similar figure. It will in fact make an imposter. So a key idea for that, you can jot down that X and Y must be multiplied by the same number to create a similar figure. Has to be the same number. Another key takeaway or key idea, this is again something we've talked about in here, angles don't change. Side lengths do, angles do not. These will be quick, meaningful notes. Let's do just a couple of examples over here. If again you start with that XY original coordinate rule, let's say you decided to make something that was similar, okay? So we'll look at some that work and some that in fact don't work. So we'll do real simple. We'll say 2x, 2y. Is that gonna make it larger or is that gonna make it smaller? It will make it larger. And I want you to think about it. In order to make any sort of coordinate rule larger, you're gonna have to multiply it by a number that is greater than 1. So if you multiply them by 3, by 4, by 5.5, by 6, 7, right? You're gonna be able to get something that is going to create or produce rather a larger similar figure. Let's say you wanted to go smaller with it. You could also multiply by a fraction coefficient like 1/3, and that would in fact make it a smaller image. And that occurs because that is something that is less than 1. So both instances, we can just look at the rule and we know what's gonna happen. You don't actually have to go through the whole process of graphing points and whatnot. Let's look at a scenario in which they are not similar. If you recall from the activity, if I did something to one coordinate, but I didn't apply it to the other coordinate, or if you kept X the same and you decided to do half of Y, this is gonna distort that shape in some capacity and it's not going to no longer be a similar figure. The last thing you should be doing with your meaningful notes is your now what do you know question. We've done a really good job this unit of making sure we kept up with it. So it says, how can you determine if an original and its image are similar by looking at the coordinate rule that produced the image? And then also tell me what features stay the same for Mug in similar figures, and then what features also changed. And by features, it just kind of discusses a little bit more of like his nose, his mouth, his legs, like those kinds of things. So be specific with your response to that. If you can answer that question, then you paid attention, you watched the video, and you are ready to move into or on to rather 2-2.